Small Scholars, and I've got some test review questions ready to go for you here, so I'm going to move quickly. These are from pages 420 and 421 in your textbook, and you can see them there, and you can go back and redo them and follow along. I just picked out a good sampling of what could be on the test on Monday. So first of all, number 27, we have a verify, and in this verify problem, we need to use the cosine of a sum formula. So I'm going to expand this out, and then we will evaluate what can be evaluated and simplified. So the cosine of a sum expands to cosine x, cosine 90 minus sine x times sine 90. And remember, we're verifying, so try not to change anything on the right-hand side, but definitely do not cross anything over the equal sign. So from here, we're going to simplify. So go to your unit circle. The cosine at 90 degrees is 0, so that cancels out that entire term. The sine at 90 degrees is positive 1. So when we substitute in positive 1, we see that we get the identity 1, so therefore negative sine x equals negative sine x. Therefore, number 27 is verified. Very simply done, simply by using the cosine of a sum formula correctly. Next, another verify problem. This one's kind of old school. Also pretty simple here. This is one where I maybe would take a look at the right-hand side and just change it to be 1 over tangent. And then we can take a look at the left-hand side. And the reason I'm choosing the right-hand side is because it appears to be the least complicated side. So I'm working on it first. When I go to the left-hand side and then I could take that cosecant up to the top, it will become sine x over tan x times sine x. The sine x cancel, and we get 1 over tan x equals 1 over tan x. Quick and easy little verify problem. All right, finally, a solve. Solve, give the general solution. So we're looking for the general solution for u. Be on the lookout for an opportunity to combine like terms. That's what we've got here. This is 4 tan squared u. This is 1 tan squared u. So when I bring this term from the left over to the, from the right over to the left and set it equal to 0, we're going to be able to combine those two terms. So that combines to 3 tan squared u minus 1 equals 0. Solve it since there's only one unknown here, so solve it for tan u because it won't factor. So we get tan squared u equals positive 1/3 square root tan u equals plus or minus, when you rationalize that denominator, root 3 over 3. Now, where does the tangent equal root 3 over 3? And once again, I remind you, we're looking for a general solution here. So tangent, the reason I chose this one, tangent's a little bit tricky. The period for the sine and the cosine is 2 pi. The period for the tangent is only pi. So what we need to do here is, if we look at the graph of the tangent, let's zoom in on the graph of the tangent. Okay. Zoom in on the graph of the tangent. Let me, I want to just get rid of that. Okay. There we go. Y equals, there you go. So here is the tan curve. Tangent x. Take a look at it. There it is. And we want a general solution here. So we're trying to determine, where does the tangent equal root 3 over 3? So what's the value of root 3 over 3? Go to the calculator here. So square root 3, 3 raised to the 1/2 power, divide that by 3. We have 0.577, a decimal approximation of 0.577. If we go back to the graph here and take a look at it, 0.577 is about right there. 0.577. So we've got, this is pi, so pi over 2 is here. It's looking like we're at about pi over 6 at about 30 degrees. So we can use the graph, or of course we can use the unit circle and say, wow, when are we going to get root 3 over 3 when we divide the y-coordinate by the x-coordinate? Well, if we divide 1/2 divided by root 3 over 2, we get 1/2 times 2 over root 3. Cancel, cancel. There's my 1 over root 3. That would rationalize to that. So we've got u equals 30. But look, ladies and gentlemen, it is plus or minus 30. So we've got to look on our unit circle and say, okay, where do we have a reference angle of 30? Well, that's 30, that's 150, that's 210, that's 330. But if I want to give this in terms of a general equation, being that the period of the tangent function is pi, I'm going to say 30 plus pi times k, as well as 150, let's see, yep, 150 plus pi times k. That's going to give me every single possible time where I could travel 180 degrees. I'm still going to have a reference angle of 30 degrees. Those are my two general solutions for number 38. Number 43, another solve. Another solving problem, and the directions in the book for number 43 say find the solutions in the interval 0 to 2 pi. So we're just looking in the interval, and this is one that I had on the calculator just a second ago. So I'm going to go back to that. I'm going to try to plug it in again. So remember, I gave you some wisdom that if we can anticipate what the answer is going to be, then let's try to do that first. So 2 times sine 2x, close parentheses, minus square root 2, close parentheses. There's our graph. We are looking in the interval from 0 to 2 pi. There it is. How many times is that graph going to cross the x-axis? 1, 2, 3, 4. Looking for 4 answers here. So this is one where we have to do the substitution. I'm anticipating that they are going to be, let's see, cutting it into fourths here. So, pi over 8 maybe? Let's see. That's tricky to estimate just looking at the graph. So we're going to do it with algebra, knowing that we're going to get 4 answers. So here we go. First of all, let u equal 2x. I'm going to write a let statement here. Change our equation now to 2 sine u minus root 2 equals 0. Therefore, sine u equals positive root 2 over 2. So, a simple solution once we allow u to represent the 2x. Now that we know that, okay, the sign is positive. The sign is positive in quadrant 1 and quadrant 2. And sine equals root 2 over 2 when we have a 45-degree reference angle. So we're talking about a 45-degree reference angle, 1 pi over 4, 2 pi over 4, 3 pi over 4. So u is pi over 4, and u can also be 3 pi over 4. We can do this in terms of radians or degrees. So if we have it in terms of radians here, remember, whenever we do a substitution problem like this and we're looking in a specific interval, first we find the general solution. So this is sine curve. The parent curve has a period of 2 pi, so plus 2 pi k. And then also 3 pi over 4 plus 2 pi k. So these are my two general solutions. Now what I got to do is say, okay, if u equals 2x and u also equals pi over 4 plus 2 pi k, then 2x equals pi over 4 plus 2 pi k. Now to solve For x here, I need to multiply both sides by 1/2 and get x equals, cancel, cancel, pi over 8 plus pi times k. Now, if we let k be 0, then that cancels out that term. X equals pi over 8, which is kind of what we were thinking. And if we let k be 1, then we get x equals 1 pi over 8 plus 8 pi over 8, 9 pi over 8. So there are our first two answers. Let's go for the other two answers with the other general solution. So if u equals 2x and u also equals 3 pi over 4, then 2x equals 3 pi over 4 plus 2 pi k. So once again, multiply both sides by 1/2 to get x by itself. That gives us x equals 3 pi over 8 plus pi times k. If we let k be 0, then x is 3 pi over 8, and that's an 8. And if we let k be 1, then we get 3 pi over 8 plus 8 pi over 8, x equals 11 pi over 8. 1, 2, 3, 4. 4 solutions in the interval from 0 to 2 pi, and we saw them all on our handy little graph. Anticipate what you think the answer should be before you start the problem. Next, number 64, and the directions for 64 say, find the exact value of the trigonometric function given that sine u equals 3/4 and cosine v equals negative 5/13. Both u and v are in quadrant 2. That's my given information. I'm asked to find the tangent of a difference. Now with these two pieces of given information, I'm going to draw two triangles in quadrant 2. So sine is positive in quadrant 2, so let u be there, opposite over hypotenuse. So 4 squared is 16, 3 squared is 9, 16 minus 9 is 7, the missing side is root 7, so negative root 7, that's my missing side for the rotation that is in quadrant 2 with u. Now for v, draw it here, also in quadrant 2. Draw a triangle. There's v. The cosine is given. Cosine is adjacent over hypotenuse. This is a Pythagorean triple, so 5, 12, 13. That's what's given. Now we're going to find the tangent of u minus v. So go to your tangent of a difference formula. I think that's on tangent of a difference. Actually, that's not in the book. You have to look for that in the cover. We wrote that down in your formula sheet. The tangent of a difference is tan u minus tan v over 1 plus the product, tan u, tan v. Of course, you can also get the tangent of a difference by first finding the sum of the difference, second finding the cosine of a difference, and then dividing that. But this is the formula to get you there a little bit more quickly. So let's start plugging in everything we know. So what is the tangent of u? Go to your diagram, find the tangent of u. Tangent is opposite over adjacent. So we get 3 over negative root 7 minus tangent of v. The tangent of v is 12 over negative root 5. Okay, so that's tan v, checking my work, 12 over negative 5, all over 1 plus the product of what we get here. This one's turning out to be quite messy. I'm checking my work in the book, seeing if I copied something wrong. Nope, indeed is messy and nasty. Okay, the product, tan u, 3 over negative root 7, and tan v, 12 over negative 5. So here's the arithmetic that we need to slog through here. It's going to get ugly. So, nothing really changing here. We got negative 3 over root 7 plus 12/5. I'm just cleaning up the signs over. And then this is going to be 1 plus, because both of those are negative, the whole thing's going to become positive, 36 over 5 root 7. Now, to clean this up, what if we multiplied by, trying to think of an easy way to show you how to do this because this is a mess. If we get a common, let's get a common denominator on the top. Times 5, times 5, times root 7, times root 7. And here, let's change this whole 1 to just be 5 square root 7 over 5 square root 7. Now at least we've got a common denominator all the way around. Moving down this way. So negative 15 plus 12 root 7 over 5 root 7 over 5 root 7 plus 36 over 5 root 7. Now, in doing that, I have set myself up to basically completely cancel those. And now I have a new and improved looking fraction, slightly improved. Negative 15 plus 12 root 7 over 5 root 7 plus 36. And I won't use much more time in finishing this, but we would need to multiply by the conjugate of the denominator. I'll zoom out so you can see a little better. We would need to multiply by the conjugate of the denominator. So I will rewrite it right down here. So we've got negative 15 plus 12 root 7 over 5 root 7 plus 36. We would need to multiply this whole thing by 5 root 7 minus 36 over 5 root 7 minus 36 to FOIL on the top. And then, of course, on the bottom, it's going to simplify. Sadly, I'm going to stop there just because the numbers are getting large. And I will say this. I would give a problem similar to this, but definitely not one where we would have a nasty radical like that that has to be dealt with. Not difficult, but definitely a lot of brute force necessary to finish that, mostly with a calculator, which I don't have close enough to start multiplying all that. That's number 64. That's how it's done. Consider the quadrant, consider what's given, draw a diagram, and then plug into the formula. Messy, messy arithmetic right there. Now, we will continue applying our brute force right here. This is number 68. The directions say to verify. So if we're going to verify, we're just trying to get the left-hand side to turn into the right-hand side. This one, the right-hand side, is as simple as it could possibly be, so leave it just like it is. This is the sign of a difference, so expand this, and we get sine pi cosine x minus cosine pi sine x, and of course the right-hand side is equal to sine x. Go back to your unit circle, go to pi. Pi is here, The sign at pi is 0. Basically, takes out that whole term. All right, back to pi. The cosine at pi is negative 1, so we have the opposite of negative 1 times sine x. There you go. Cancel, cancel. Sine x is equal to sine x. And you are verified with not a lot of brute force on that problem. That's number 68. 73. Once again, solve. We're solving in the interval from 0 to 2 pi. This is going to take up a lot of room because this is the sign of a sum minus the sign of a difference. So before we even try to plug it into the calculator, let's expand it as best we can and see that something cancels, which it will. So we get sign of a sum. So sine x cosine pi over 2 plus cosine x sine pi over 2. Keep that all together, and we're going to subtract the big difference that we will get here with this sign of a difference. Keep it in brackets. So sine x cosine pi over 2 minus cosine x sine pi over 2. Close that bracket. The whole thing's equal to root 3. Now, back to your unit circle, and let's simplify some. Pi over 2 is 90 degrees. The cosine at 90 degrees is 0. That term cancels. That term cancels. So we're left with cosine x sine pi over 2 minus minus plus, the minuses cancel each other, cosine x sine pi over 2 equals the root 3. Let's go ahead and simplify that. The sine at pi over 2 is 1, so those just go to 1. So cosine x plus cosine x is 2 cosine x equals root 3. Divide by 2, divide by 2. Cosine x equals root 3 over 2. Where is the cosine positive? The cosine is positive in quadrant 1 and in quadrant 4. We're only looking in this interval, so look in these two quadrants. Where's the cosine x equal to root 3 over 2? It's equal at pi over 6 and at 11 pi over 6. X equals only two answers, pi over 6 and 11 pi over 6. That's radians. If you want it in degrees, it's 30 degrees and 330 degrees. Either one I'll take. That's number 73, solved in the interval from 0 to 2 pi. Next, evaluate with a half angle formula, theta equaling negative 17 pi over 12. And the complete directions for number 86 say, use the half angle formulas to determine the exact values of the sine, cosine, and tangent of the angle. So first of all, what is negative 17 pi over 12? I would change that to degrees, and when you change it to degrees, it's negative 17 pi over 12 times 180 over pi. Pi's cancel. 12 goes into 180 15 times. Negative 17 times 15 is negative 255. Now, okay, negative 255, not a very easy angle to wrap our brain around. But what is coterminal with negative 255 degrees? Well, if we think about this, draw it. Negative 255 degrees is going to be negative 90, negative 180, and then a little bit more to get to negative 255 right there, because all the way to the axis would be at negative 270. So what do we have here? Let's just subtract that negative 255, or add it, I should say, to 360, and we'll find our coterminal angle here. And I'll draw that in yellow. There's the coterminal angle. It is 105. So, if negative 255 is coterminal with 105, then I can replace theta. Instead of negative 17 pi over 12, I can just say that it's exactly the same rotation as 105. And I'm asked to do it with a half angle identity. 105 is equal to 210 divided by 2. So I'm going to go to my half angle formula and let U be 210. The half angle formulas are on, where are they? Last page. Half angle, here they are. They're on page 410. It is, first of all, we're talking about 105 degrees. 105 degrees is in quadrant 2. The sign is going to be positive. The square root of 1 minus cosine 210 over 2. So 1 minus the cosine to my unit circle. The cosine at 210 is negative root 3 over 2. Plug it in. All over 2. Extend my radical out there so I can dump those fractions, and my sine of 210 divided by 2, or sine of 105, is going to be positive plus plus, distribute, and I get 2 plus root 3 over 4. The square root of 4, of course, will rationalize and come out from under the radical, so square root, positive square root of 2 plus root 3 over 2. That is your sine of 105 degrees. We're going to do that same thing again with the cosine. I'll skip that one. I'll go ahead and go to the tangent just to kind of round out this problem. The tangent of 105 is equal to the tangent of 210 divided by 2. So we go to our tangent formula. You have two options there. Choose whichever one you like. I usually go with the first one because there's only one term in the denominator. So 1 minus cosine u, u being 210, over sine u, over the sine of 210. Go back to your unit circle. The cosine at 210, the cosine is negative root 3 over 2. 1 minus root 3 over 2 over the sine at 210, negative 1/2. Dividing by negative 1/2 is exactly the same as multiplying by negative 2. So flip that negative 2 up to the top, multiply it through, and we're done. We get negative 2 plus root 3. That's your tangent at 105. Boys and girls, that's your review questions that I've got for you. For your test that's on Monday, we'll be doing a whole lot more questions next week after our test, our 2 days of review. So next week, we have a test on Monday. We then have class on Wednesday and Thursday. We will be having review. And also remember that Friday afternoon, a very super special volunteer time together from 3 to 4 after school next Friday will be Precalc review in Miss Hendry's room. So please take advantage of that if you have extra questions next week. Have a great weekend.